Okay, so this is chapter 6, data description again, but today we are going to learn about group data. Okay, so let's go straight away to the first example. So for example, the distance in kilometer the teachers live from their school are as below. So we have the distance on the left hand side and then the number of teachers on the right hand side. So these are also known as the frequency. So on our right hand side is the frequency. So we have to estimate the mean, the median, the mode, and then the first quartile, third quartile, as well as the percentile. So this is what we have to learn today: mean, median, mode, quartile, and percentile. Okay, so let me proceed with the mean. Okay, so this is the first example. The distance in kilometer the teachers live from their school are as below. So we have to estimate the mean. So firstly, do add another two columns. So the first one is for the midpoint, where we normally denote it by x. And then another one is the column for fx, where f is the frequency. So the number of teachers is the frequency. And then we're going to multiply them with our midpoint to get fx. Okay, so 0 until 10. So to get the midpoint, we have to do 0 plus with 10. And then we divide them by 2. So that is how we get a 5. And then the second one is 10 plus with 20, divide them by 2. So we are going to get 15. And then of course 20 plus with 30 and then divide them by 2, we are going to get 25. 30 plus 40 over 2, so this is 35. 40 plus with 50 over 2, so this is 45. So this is how we obtain our midpoint. To obtain your fx, you simply multiply along the row. So 4 times 5, 15, 15, 27, 25, 18, 35, 6, and 45. And after that, don't forget you have to take the sum. So at the end over here, this is the summation for fx. And then this one over here is actually the summation of the total frequency. So 4 plus 15 plus 27 plus 18 plus 6 is actually equal to 70. So using the formula, the mean is summation for fx over the summation of the frequency. So summation for fx is 1820 and then divide by the total frequency, which is 70. And when we divide them, we are going to get 26 as our mean. Okay, so let us proceed with part B. So B, we have to calculate the median. So the formula for the median is LK. So this is the lower boundary for your class. So this is the lower boundary for your class. And then of course we have to calculate n over 2 so that we know where is the class. F stands for the cumulative frequency. K minus 1, that means cumulative before the class. Cumulative before. And then the small f stand for the frequency. So this is frequency of our class. So K stand for our class. K minus 1 stand for the class before us. And then C is simply the class size. Okay, so when you want to answer this median, you will need one more column, which is called the cumulative frequency, because as you can see the formula over here, we will need the cumulative frequency. Okay, so firstly, I need to know what is n over 2 so that I know where is the median class. So n over 2, the total frequency is 70. So 70 over 2, so this is equal to 35. So 70 over 2 is 35. So let us find out where is 35. So this is 4, this is 19. So this is where my median lies. So you can use your highlight and then highlight this row, as it will help you a lot. Okay, so how do we read this cumulative? 4 means that the first data until the fourth data is here. This is the fifth data until the 19 data. The 20 data until the 46 is here. 47 until 64 is here. The 65 observation until 70 is over here. So that is how we read the cumulative frequency. So we want to find 35, it is simply inside here. Okay, so we are going to use the formula. So the lower boundary for this, so we're going to take this value, add with the previous one, so 20 plus 20. You divide them by 2, so that is simply equal to 20. Plus n over 2, I already calculate them previously, which is 35, minus cumulative before our class, so this is my class, the one before that is 19, so this is 19, over cumulative the frequency, so I have to divide by the frequency of its own class, so the frequency is 27, multiply with the class size. So how do we know the class size? So referring to here, the lower boundary just now, we know that the lower boundary is equal to 20. So now let us check the upper boundary. So this is 30 plus with 30. So 30 plus 30, divide them by 2. So we are going to get 30 as well. So of course, upper boundary minus with the lower boundary. So you can get the class size, which is equal to 10. So this is 10, and then using the formula, substitute everything into our calculator. We are going to get 25.93 as our median. Okay, so now I'm going to teach you how to check what is the class size for every interval. So let's see some example. Okay, so for the first table, if let's say I'm focusing on the second row, the lower boundary for this row is 6 plus 5 over 2. So the lower boundary is 5.5. Meanwhile, for the upper boundary, I have 11 plus with 10. So that means the upper boundary is 10.5. So if you calculate the class size, the C is actually equal to 5. So 10.5 minus 5.5. So the class size is 5. Okay, so meanwhile over here, let's say I want to refer to the third row. So for the third row, this number here is 4. This one is also 4. So 4 plus 4 over 2. So that means the lower boundary is 4. Meanwhile, for the upper boundary, so we have 6 over here, 6 over here, 6 plus 6. So this is simply 6. So if we were asking about the class size, so the class size will be equal to 2. Okay, so for example over here, this one looks slightly different because as you can see, we have a cumulative frequency. To make it much more easier for you to understand, perhaps let us try to write down the x, and simply use less than equal, less than equal, less than equal, less than equal. So this one will be 0. Take this number, this is 5, 10, and 15. Okay, of course, this is cumulative frequency. If you want to know the frequency, you have to deduct them. So this one is 5. The frequency is 5. 8 minus 5. So this is 3. And then this is 7. So this is how you calculate the frequency. Simply deduct them. Okay, so now if I'm asking for this interval and I want to know the upper boundary and the lower boundary. So the upper boundary, this is 15, plus with 15, divide them by 2. So the upper boundary is 15. The lower boundary is 10, plus with 10, divide them by 2. So the lower boundary is simply 10. Therefore, the class size will be equal to 5. So that is how we read the class size. So let's go to the next example. We have to estimate the mode. So again, similar problem. So LK, again, this is the lower boundary. So D means the different. So different before. D2 means that the different after. Okay, so now let's see what do I mean by the difference. So firstly, you need to know where is the class mode. So based on the frequency, check which class will has the highest frequency. So the highest is 27. So this is our mode class or model class. So this is the class that we are working with. So now the lower boundary for this class. So we got 20 plus 20 divided them by 2. This is 20 plus. So the difference before them, the difference in frequency. So you can see here 27 with 15. So 27 minus 15. So this is 12. So that means the D1 is 12. So 12 over 12 plus. So 27 together with 18. So this is 9. So plus 9. And then, of course, you need to times with your class size. So the class size is 30 minus with 20. So this is equal to 10. Therefore, the mode is simply 25.71. Okay, so now the first quartile, if we refer to the median, this formula is almost similar to median, except that now we have a quartile. So you can actually remember them by remembering quarter. Quarter is actually 1/4, so the first quartile means 1/4 of n. If you want to calculate the median, median is actually half, so it's supposed to be n/2 or half of n. Okay, so similar, everything is similar except that now we have n/4. So let us find out where is the n/4. So we got 70 over 4. So the answer for 70/4 is 17.5. So now let us see where is 17.5, where is this class. So it's supposed to be somewhere inside here. Okay, so let us take the lower boundary for here. This is 10 plus. So now n/4, we already calculate 17.5 minus cumulative frequency k minus 1 simply means before them. So this is the cumulative frequency, so before them is 4 over f is the frequency, so this is the frequency. K means the class itself, so the frequency for the class is 15. And then of course the class size is 10. So by calculating, we should be able to see that the first quartile is equal to 19. Okay, so the third quartile. So like I told you before, the third, that is why we have 3/4. So 3/4 times with n. So firstly, we need to know where is 3/4 times n. So 3/4 multiplied with 70. When you times them, you should be able to see this is 52.5. Okay, so 52.5, referring to the cumulative frequency, it should be somewhere inside here. So the lower boundary is 30 plus 52.5 minus the frequency, the cumulative frequency before our class, which is 46, divided by the frequency of your class, which is 18, multiply with the class size, which is 10. Therefore, this is simply 33.61. Okay, so let us go to the last one, which is percentile. Okay, so the formula is LK plus K over 100 multiplied with n. Again, if you look at them, this is almost similar with median, except that now we have K over 100 times with n. So percent, it should be over 100. So 40 percentile, that means the K should be equal to 40. Okay, so firstly we need to know where is the 40 percentile. So 40 over 100 multiply with the total number of data. And then of course this is 28. So based on the table, 28 is somewhere inside here. So we are going to use this formula to calculate the 40 percentile. The lower boundary is 20 plus 28 minus cumulative before that class, which is 19, over frequency of the class 27, multiply with the class size 10. Therefore, the answer for this one is 23.33.